Hey guys, today we're going to be going over USACO 2018 January bronze lifeguards. So in this problem, Farmer John has opened a pool for his cows, and in this pool there are N lifeguards. So the pool opens from time t equals zero until time t equals 1000. And so a lifeguard shift can basically be described by two integers, the first one giving the starting time of the cow's shift and the second one being the end. So for example, a lifeguard starting at time t equals 4 and ending at time t equals 7 covers 3 units of time. So basically they would cover time t equals 4, 5, and 6, but not 7 because it's 3 units. So just keep that in mind. And unfortunately, Farmer John hired one extra lifeguard, and he has to fire one lifeguard out of all of his lifeguards that he has. And so, what's the maximum amount of time that can still be covered by the shifts of the remaining lifeguards? So, that's basically the question that we're tasked to answer. And um, a interval of time is covered if at least one lifeguard is present, because there may be times when there are two lifeguards present. So a shift is still covered, one lifeguard is there, shift is still covered, zero lifeguards are there, the shift is not covered, or the time is not covered. So you guys get the idea. That's like common sense. But in the input format, we get n, right? And the next n lines describes a lifeguard in terms of two integers in the range 0 to 100, giving the starting and ending point of a lifeguard shift. All endpoints are distinct. Shifts of different lifeguards might overlap. So as you can see, this is n, and then these are the shifts, right? And for the output, we need to write a single number giving the maximum amount of time that can still be covered if Farmer John fires one lifeguard. So in this problem, it happens to be 7. And we can just move to a graphical view, and I'll explain why it's 7. Okay, so basically this is the starting points of all the lifeguards, and this is going to be the ending points of all the lifeguards. And so let's go ahead and draw them out. So we first start at 5 through 9, right? So we're gonna have a shift that goes from 5 to 9. Then we're gonna have a shift that also goes from 1 to 4. And we're also gonna have a shift that goes from 3 to 7. So 3 to 7. So we need to cancel one of, or fire one of these lifeguards, right? And so if we fire the lifeguard that goes from 1 through 4, the times covered will be 3 through 6. So obviously, that would mean that we cover 6 units of time. So I'm just going to write to the side, if we fired if we fired 1 through 4, we would cover only 6 units of time. And if we fired 5 through 9, right, then that would mean we cover times 1 through 7, which is also 6 units of time. However, if we fire 3 through 7, we would cover 1 through 4, which is 3 units of time, and 5 through 9, which is 4 units of time. So that would mean that we cover 7 units in total. And you can see that this shift basically overlaps with a lot of the other two shifts, so it would be reasonable to fire this lifeguard to make it profitable for Farmer John. So yeah, that's the idea. We're just doing a complete search and trying to find which lifeguard we should cancel, or sorry, fire. I keep saying cancel. But now we can move on to our programming part. Okay, so we already have some static variables here. N is going to show us how many shifts there are. Range is going to store the starting and ending times. And T is going to tell us when a time is covered and when a time is not covered. So let's first start by setting up N. This will take in N and store it. And then we can set up our range. It's going to be N and 2. This n is going to be the rows, so it's going to have n rows, which will have 2 columns, and those columns will basically be for the starting and ending times. And then we'll set up t as well. It's going to be equal to 1001 because If we're going to access indexes, we need to be able to access indexes 1 through 1000, or sorry, 0 through 1000. And so in order to do that, we have to put it one more than 1000. And the next thing that we're going to do is now actually set up the range 2D array. So we're going to need a string tokenizer here just because we have multiple things on a line. We'll set that up. Okay, and then we'll set up our the range values. So it's going to be range I of 0 equals integer dot value of st dot next token. And we're going to do the same thing on the next line just for the second column. Okay, so that's going to set up our entire range array pretty much. And now that everything's set up, we can move on to our solve portion. So in the solve array, or sorry, in the solve method, what we're going to do is we're going to do a complete search. And what I mean by that is we're going to omit one lifeguard every time during our for loop, right? We're going to have a for loop, and each time we go through the for loop, we're going to omit one lifeguard and only one lifeguard, and we're going to see how many time units we can cover. And basically, those time units will eventually we'll find the max inside of those, and that'll be our answer. So in order to store the max, we first need to have a variable to do that. And then we can start our for loop. And then we'll have a nested for loop. The reason why I do this is because the outer for loop is going to be the lifeguard that we emit. So basically it's going to start at 0 and cover all of them. And then the inner for loop is just going to gather the shifts of of every other lifeguard. So we're going to do if I is not equal to j, right? Because we want to omit I. Then what we'll do is we're going to set the proper values of t equal to true. And then the starting value that we start at is going to be j of 0, right? And then we're going to do this all the way to j of 1. Remember, we don't include j of 1. And then we will close that. And then once we do this, we can just set this equal to true, right? So all of the basically all of the lifeguards will be present except the ith one here, okay? And now that we've done that, we can have a temporary variable here, and we're going to count. We're going to see how many true values we have. Okay. And we'll just do if t of j, because t is a Boolean array, then sum plus plus. And now we're going to use a ternary operator to check whether max is greater than sum. So we're going to do max equals sum is greater than max, and then sum, oh, I used the wrong symbol, sorry for that. So this is going to check max is equal to, we're going to check this condition. If this is true, we're going to set it equal to sum. If this is false, then we're going to set it equal to max, okay? And after that, all we need to do is just print it out. And so that's pretty much our solution. So to review, we basically have n and range, which is our inputs, and they tell us what shifts we have and how many shifts we have. And t is going to be telling us which parts of time are covered and which are not. We set all those up here, and then we have a max variable that's going to store our answer. We go through these, and basically we're just going through all of the lifeguards except one, and we set all the shifts equal to true. So all the shift starting and ending times, any time included during those times of all the lifeguards is going to be equal to true. But the ith lifeguard will not be working during this during these for loops. And we do this for all of the n lifeguards, right? We don't miss a single one because we're doing a complete search. And we basically just find the maximum amount of time that can be covered when we omit one lifeguard, right? And then we find that and we print that out. And one more thing, we have to add a line of code. So basically, at the top here, we basically have to reset our t every time every time we run through this for loop. So we're just going to reset it here using this. And the reason why is because basically we want to check after emitting every lifeguard, right? So after we check for that specific lifeguard, if we don't remove it, then some of the elements of T might be true and they might not be overrun by these. And so it just causes, confusion and it will give you the wrong answer. So you need to reset T after every for loop run. And now we are ready to submit. As you guys can see, we passed all of the test cases. That's the lifeguards problem. If you guys have any questions about it, feel free to leave a comment. And as always, thank you for watching.